So this is Python. First, I will be discussing about Python things, and I will be going back. Okay. So what are generators? Okay. Generators are way to create generators are way to create your what do you say, mm, an object which is capable of executing function without directly invoking it. Okay, so I think it will be clear if you see a very small example. Generators. Okay, so what is it? A function returns a generator object. Using this generator object, we can execute the function by maintaining the state. Right? Okay, so let me show it by code. Okay, so we go to the function my generator. Suppose you have a function like this. Okay, very simple function. Okay, so in here, what are you trying to do? Okay, in my generator, you had I equal to 0 while true, right? Yield I plus so see this. What is this function generator? This is the function, and you see a special keyword yield here. Okay, so whenever in fact this, just understand yield similar to okay generator function generator object function should contain yield. Okay, generator function should contain yield. So what will yield do? Yield is similar to a return, just that it will maintain the previous state of the function. Okay, yield is similar to return, just that it will maintain state of function. Okay, so when I call this, okay, so when you do this, f is equal to, if you do this, so what will this guy return? This guy will return a generator object. Okay, now what is actually function is return? It should return 0 first, then 1, then 2, then 3, right? That is how it should return. So to do that, what you have to do? Zero, 1, right? So this guy will return a generator object, this function, my generator, and whenever you do a next, it executes this loop one time. It will return I values as 0 first time. It is waiting at yield. When you call f.next, it will execute. So you don't actually have to maintain any global variable to maintain the state of the function. So what is it doing here? It is maintaining the state of the function. Okay, so in a nutshell, generator are the way by which you will be maintaining state of the function. Okay, so that's how generators work. Internally, there are a lot of libraries which uses the concept of generators. Okay. So internally, you have a lot of libraries which uses the concept of generators. See this utility next. Okay, so it is never ending. So what are the benefits of generator? Benefits of generator, it very much optimizes the memory that is consumed. Okay.
So where are we using generators? To generate unique ID?
No, generators are used everywhere in data science. Okay, because data science needs. So in this case, suppose you are reading a file or say pandas, right? It has huge. It maintains a lot of data. Now, if you bring all the data to your memory will be exhausted. So rather than bringing all the data in memory, it uses next. So whenever it is required, it will get some piece of memory from some piece of data from the file
some
system.
CSV file.
Right,
Data,
right. All of these things are internally using generators because generator are the things which actually make your system, make your program, independent of data size. Okay, because using this concept, you can slowly up, use the data, and when you're done with the data, you can relieve it. So you are using the entire context, right? So you have a lot of libraries which is written using it. So we have something called import iter tools. Okay, for iteration, this is used. So iter tools dot chain pass here a list. Okay, so if you execute this guy here, let's go. So f dot next, right? You'll get 0. Similarly, f dot next, you get 1. The chain means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, it will be 0, 1, 2, 3, 4, 5, 6, 7, 9. It's infinite. So this is all achieved using generator. So everything, whenever you have some data structures which provides you a lot of high-end performance operations, right? They are invariably implemented internally using generator. Understood, right? Okay, this is the concept of generator here. Okay, generator is used extensively throughout. Now, okay, so always remember it is extensively used in this data frame APIs.
Okay, their backend they are
used, right. Okay,
but we are not going to specify this internally.
You are not going to use it, but you should know it because in interviews, in discussions, in debugging, right? You should be knowing this generators. You have to know the concept, and you might have to write generator at times. Okay, so right where if you want to delay processing. Okay, so in this case, you can delay the processing, right?
Yeah.
Right, because every time when you call it only, then it is called lazy loading operation also. In Spark and all data science and our high-end machine, processing stuff, you use these guys to delay the processing. That is what this guy said. Now, this is all about generators. Okay. So now we'll see decorators. Okay. What are decorators? This is a mechanism to control the flow of execution. This is a mechanism to control the flow of execution of program. Okay, so traditionally, if you are defining a function, when you call that function should be executed, right? But not with decorators, you can control it. You can provide security over the function.
Like who can execute on?
You can provide security. You can make sure some other function should be called before this function. Okay, this is what you achieve using decorators. Okay, let's see. Provide this. This is used in providing access to a function. Right? This is used in providing access to a function. Doing some additional work before / after function. Right? Let's see. The writing in this code is a little dirty. Syntax is not very intuitive. Let's see. Suppose you have a function. My function. Okay, it is of course not taking any parameter, and it is printing hello my function. Very simple function. And how do you call it? You call it using this my function. Right? Nothing surprising here. All same. Now all of a sudden you think you want to control the execution of this. You want this function to be printed only if some condition is true. Only some condition is true. Let's see. Okay, so what you do here, you annotate this guy. This is known as annotation. Okay, this is known as decorator. We consider annotation here. Check if valid. So you have an annotation whose name is check if valid. So that means no. You are you can create one with your name also. So now with this, what I want to check here is I want to check whether it is valid to execute this function or not. Check it. This is just a function call. Okay, we pass here a function. Okay, so you have check if valid, and you want to do some checks here. Okay, so now in this case, you'll have another internal function. Function within a function is known as internal function. I'm writing another function here. Internal function. So function within a function. Okay, this is internal function. Hmm. Is it training tool? Then you have print. Then you have in print before function call, right? Then you call this guy function. Okay. Then after function call, right? Then here you will return internal function, right? So now if I execute this guy, what is happening? This guy is now controlling. Now before even entering this function, it is going here. Okay, this internal function. What is this returning? This is returning an internal function object. Returns internal function object, right? So this is a function you are defining internally here. So what it does, this is the function which will control execution. So here before this, before function call, you can write a condition also, right? And the condition.
So, no need of the internal function, right? You can write.
No, because this and this decorator function should return.
So it should have a function. Decorator function should have a function.
Decorator function should return a function. Okay, that function is a function which will control the execution of your main function. Right? You can write a case here. Like in this case, I can write here. I will generate a random number. And if the random number is greater than 0.5, it will work. If it doesn't work, it will not import if say this the usage. Oh, small I am. Just 1,5. So you see, in this case, it is executing this. 1,5. One is regenerate. So that in this case, is not getting executed, right? So based on that, you can write. In this case, it is getting executed, right? So you can actually write some condition on when you want to call. That is, these are the concepts of decorators. You have a code. If you have to control the execution of the code, you can rely on this. Okay, so this is the concept of your Generators and decorators.
Any questions, guys? Or folks who are attending online?
Yeah, Rashmi, where is Muzaffar? You went offline. Okay. Now, what was the last thing we were discussing in pandas?
They're about to start access law because extra field
Uh,
goodbye and apply on the super.
Okay, let's get started with. Of course, you can actually do more stuffs in this decorator. You can pass arguments also here. Okay, how can you do that? Suppose this is a function which takes one argument. Now, hello world, and it prints that argument. So when you are calling, this will pass with. 100. Okay. Suppose volume. Now, when you are doing this, this function should take num. Okay. Here, num is equal to see, you got passing 100, but actually what is getting printed is 50 in this case. Okay, so that is how you are controlling the variables.
So what you did is that you are passing this 100 to the inference function.
Right, 100 is very fast here, and in this guy,
Or in your
dividing it by 2. So whatever the value you pass, you are controlling the argument. Also, you can do some checks also. That means this argument value is this. Don't use this. Use the default.
so that func of num is a my function of num. Again, it is called into the my function. In the inference function, you have written that func of number.
Right.
That is the my function of num.
Right. Right.
Same number will be.
Same number value. That is how you will usage it. See this really simple function. Understand it. So now go to back to our pandas. Hi Rashmi.
Hi.
Okay. Okay. Yeah. So you were able to see the screen and follow the stuff thoroughly, right?
Yeah.
Okay. 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 The Jupyter screen is visible to you, right?
Yeah.
Okay.
Yeah, it is visible.
I'm recording it anyways because two of the folks are not present today. Muzaffar came, I
Okay,
think
fine.
he logged out actually. So I'll be sharing the recording. I'll proceed with pandas related stuff. Okay, so
Yeah, sure. Yeah.
pandas. We did adding, deleting columns, stack, unstack. We did.
No, we didn't.
Okay. 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 Let's now create a simple data frame. E is equal to simple dictionary first. One and pass the list 1, 2, I will okay. Okay, so how can you create data frames here? df is equal to right the data frame pass data is equal to d in in x is equal to I, right? So if you do this, then this will create a data frame like this. If you want to get all the index, what do you do? df dot index, right? You are getting all the index like this here. Now there is a concept of stacking. Okay, stacking means it will convert this into some other format. Okay, which is, so if you do df dot stack, it will be in this format. This is the column name. A1 is 1, A2 is 2, B1 is 1, B2 is 2. Okay, it is converting this format of data to this format. Okay, when it's stacking. So in this case, suppose I'm storing the information in some variable STs. I'm storing the information. Suppose you do this. So you do this stack dot index, right? You'll get levels. The first guy is your levels A B. After this you have 1 and 2 as option. Then you have levels 0 0 1 1. How is it happening? Okay, so this is what stacking means. It can convert your data into row format, where each row gives you information, everything about the data. Okay. Let's see. Okay. Now you have abilities to do transpose. So what is transpose?
Move to column.
Row to column, column to row. Okay. So you will see some application of stacking. So it will make it clear if it is not clear now. Okay. So let's see some application. Zulu df dot cap d. Right. So it just change row into columns and write column into row. This is many times required. It says right you want how many products were sold, how many times, so weekly products say information, right? So your columns must be product, rows must be weeks. You want to convert into products and then weeks because your system is more comfortable doing column processing rather than row processing. Okay, I mean pandas is more comfortable doing column processing rather than row processing. That is where this guys comes into action, I suppose. We have done group by, right? Okay. Then So you have a lot of ways by which you can calculate standard deviation is there, right? Okay, now we'll do some mathematical calculations to understand. Okay, first we'll load some data. Okay, so I'll have to send a new meeting invite because this will expire in next 2 minutes. Okay, so please, if you have WhatsApp, just tell them to rejoin. Okay, so stop. Okay, so I'll be sending a new meeting invite. Please,
Okay.
and we'll start after 5 minutes. Okay, please get some water. Okay, I'll be sending a new meeting invite shortly.
Okay.
So